Hello. So we are back Tuesday morning, and I just got a package from someone. Okay, and it's a nice letter. I really enjoy it reading this, and also the man said, you know what, just do a video fixing because I tried replacing the faulty MOSFETs using the famous soldering wire, but didn't work. Okay, and also he sent me the wire, but the problem is, you see this wire. This is not a proper calibrated fuse. You need a proper wire to fix it. Okay. Okay. The guy, he said, just fix it and do a video, and we can keep it for spares. But anyway, let's try and fix it. I was struggle to find the shop address. That's good. That's the idea. Yeah. So what do you think? We should fix it. It's just a morning when I have the coffee and actually reading a nice letter from a subscriber. Okay, so let's have a look and see what we have here. I didn't open, so I don't know. Okay, based on the heatsink, must be a new one. That's all. We have a RAM memory. Okay, we have a fan. We have two components, which I believe are two MOSFETs. Obviously, we can see there are two MOSFETs. We have a CPU. We have the charging port. It's like a puzzle. We have the power button here. Like a puzzle. We have the heatsink. We have another heatsink. This is an old one. And we have the board. This is a nice board to be fixed. Come on, I made so many videos about this thingy. Fixing this. And you can see here, look, I can spot a wire instead of the MOSFET. It's just, the things don't really work like that. You remember I told you follow the first MOSFET, the second MOSFET. You can see those are power supplies. Coil to MOSFETs, yeah? These are power supplies. So the input MOSFET should be near to the charging port connector. So the charging port connector is this, yeah? You can easily see here like two MOSFETs, and then you have the current sensor there. So probably one of these MOSFETs. Yeah. Yeah, because these two MOSFETs are with this coil together and is for the charging circuit. So probably these two MOSFETs are the first two MOSFETs. Okay? I'm just saying. Yeah, the board is overworked. Looks like a old liquid damage. Probably has been cleaned. The button is the mouse button. Okay. The Super IO, we have a Novoton. But you can clearly see it's water damaged. So let's try and fix this. Yeah. Let me get the charging port. Power button. So the processor is there. This is just for spares. Oh yeah, the processor is there. Okay. Okay. Let's see the power button. Let's remove this bridge first, yeah? Oh, the power button looks like it's gone. I mean, look at this ribbon cable, and you can see the metal pins just got out from the board. Okay, don't worry, it's fine. We don't need it. Charging port. Let's see the charging port. This is not from here, or what? Do you see any other? No, should be from here. I don't think it's from here. So one more time. So what is the power? But what is the power connector? This one. I mean, must be here, but it's not this one. I swear it's not this one. No, it's not. These are the same. Like, you know, it's not going one to the other. You know what I mean? Are exactly the same. So how can I fix it without the power board? Hmm? Let's see. Let's remove that bridge first. Let's see. So the input circuit must be where? Must be here. So this is the input. Here is must be the plus, yeah, here. Okay, let's use a wire. Let's solder a wire. So this is plus. Good. Plus 19 on the power supply, minus, and it's taking 40 milliamps, and it's going to 0.04. Yeah? Let's try and find the power button. I mean, it's looking 40 and it's dropping to 4. Hopefully the Super IO is good. We can check the voltage. Let's check to see if we have 3.3 on the Super IO. And no, we don't. Current sensor, do we have 19? We have 20, it's fine. But why is taking 40 milliamps? Because something must get, you know, warm, hot. 40 milliamps, it's... Okay, this thing is getting hot. And he knew about this because I can see it's worked. Yeah, so this is the power supply. It's the driver for these two power supplies. Yeah, give me 1 second. Okay, so the thing is getting hot. The driver of those power supplies. So let's have a look. So why this can get hot? I can see someone work here. You can see that. Let's check the output of these power supplies and see it's any short there. No, it's not short. 3.3, let's check the 3.3. It's not short, but let's come with the 3.3 volts on the BIOS chip, yeah? Let's see. We have a dead super IO. And he's taking 1.1 amps. That's sick. Hey, but he's not taking by the super IO, yeah? He's not taking by the super IO. Who is taking 1.5 amps? Who is taking 1.5 amps on this board? On the BIOS chip plus. This is crazy. Don't tell me the chipset. Yeah, the chipset. Wow. So that means the 3.3. This is not the BIOS chip. This is not the BIOS chip. Has an internal BIOS thingy, and this is the actually the chipset memory. Okay, let's find the power supply of the Super IO. But anyway, looks too high. 1.5 amps on that thingy. Okay, it's not short here. I can't see any plus. Maybe this one. 1.8 amps, same story. And the chipset, yeah, the chipset is getting warm. No, actually, the Realtek thingy, this one is getting hot. Lol. Okay, let's check the output of these two power supplies. So here is taking 1.1 amp. Okay, chipset is getting hot. And here is taking 0.6, which is fine. That probably does the 5 volts. That means the 3.3 volts should be one of this pin, yeah? The 3.3 should be generated here somewhere, yeah? So we have 3 point, yeah? Let's see here. It's taking 0.3 and here 0.6. So I can't see any short. Let's see what chip it is. Let's see what chip it is. Hmm? We can fix it quickly. What is saying on the chip? I can't see. I can't see what is saying on the chip. Let me clean it. Let me clean it. One two two five. 1225C. Okay, I'm pretty sure we can find this chip. I'm pretty sure we can find this chip. Where is my chip? I'm pretty sure we can find it. If this is burned, we can find it. Yeah. But first, before we are replacing this chip, let's do some testing. Yeah. Yeah, it is solder. Don't worry, it is solder. 1225. 1, 2. Let me find the data sheet quickly. Yeah. 1, 2. Give me 1 second. It's a TPS chip. Let me find the data sheet. You found it. Found it, yeah, found it. Dual synchron step down controller, 5 volts and 3.3 LDO. So VREC free, that's what I'm looking for. For VREC free. VREC free is here. And it's fine. VREC free is fine. No shortage. Okay, let me come with the power supply. Yeah. 3 volts. And we have ground. And this should be 3.3 and it's taking 30 milliamps, which make me believe actually the chip is burned. Yeah. Let me find this chip. It's a TPS chip. Hopefully I can find one. It will take a while, so if you get bored, just fast forward, please. Yeah. Five one two one six. No, not that one. Hmm. 5116. No, close, close, but not that one. but close. Five one 1 2 3. No. Can be this one. I can't see anything. No, this is a big Q. Found it, found it, found it. Yeah, that's the one. Yeah, so check here. 51125. Okay, that's the one. Let's get the chip. Now let's see, that's the problem. As we can fix it. Wait, it's not looking the same. Wait. Oh yeah, it is. Oh no, it's not. What? No, it's 1225. 1225. See. So what I'm looking at? 1225C. Okay. Sorry. Hmm. Okay. Okay. 1225. Let me switch the camera because it's boring. Hmm. That will be long. One two two five C. Yeah, found it. Found it. Okay. Found it. Found it. Yeah, that's the one. Yeah, that's the one. 1225C. Yeah. Okay. So the old chip is out. The new chip. Okay, that's fine. It's soldered in place. Yeah. Let's see now. Plus 19. Minus. Still hot. Okay, plus minus. Yeah. It's take 450 milliamps. Yeah, but that's fine. 450 and is going to 0.01 eventually because probably it's working. Yeah. Let's check the output. Have the multimeter on screen. On the output we have, check on the screen, 3.3 volts. Yeah, 3.3. So we managed to bring back to life the VREC 5, the 3.3 volts one. I mean this one. A second. This one, yeah. So on this one, you have a permanent 3.3 volts. Where can I find it? Yeah, here. Yeah, VREC 3, which is permanent 3.3 volts. This one, you see, 3.3 always on. Okay? Good. Now let's solder back the MOSFET what man took it out. Yeah? Oh, but doesn't have pins. Okay. Let's see what he's doing, this MOSFET. Nothing here. And nothing here, yeah? So we have no voltage on this whatsoever. Now let's try to find the power button. So that means the Novoton chip will be... We should have 3.3 here somewhere. I don't know what pin. Okay, let's find the power button, please. Yeah, power button must be this one. Yeah, this one. Let's check with the multimeter. Zero, 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 zero. Maybe that's not the power button ribbon cable. Maybe it's this one. Let's see. 0, 0, 3.3. That's the ribbon cable for the power button. Let's try and short and power on. Nothing. Oh yeah. So we started and it goes off again. Wow. So we start the laptop from here and 0.4 and it's going to 0. Okay, let me check something. I want to check the voltage on this MOSFET which was removed. Okay. And 3.3 and it's going to 0, and on the other side we have nothing and it's going to 0. Okay, so we need a MOSFET. This MOSFET is passing the 3.3 volts. The man said he bought two MOSFETs. Okay, so what was the original MOSFET? Let's see. B 4468, and the new ones 4468. Wow, the man bought exactly the MOSFET what was there. Great. Okay, so let's solder this MOSFET back here. Okay, it looks a little bit messy. Okay, looks fine. Let's solder the MOSFET. I mean, we can solder with a solder iron. It's a big MOSFET. Yeah. You know what? I lost it. The MOSFET jumped somewhere, and I have no idea where. You know, that's why I always buy like two components. Just be sure if I lose one, I still have the other one. It's a good practice to buy like 2 components. And then I solder the MOSFET. Oh, what do you think? Looks fine, yeah? Looks fine. Looks fine. Let's test it. Let's test it. Ground. Good. Power on. 0.4 and it's going back. Okay, now it's bad then. Now it's bad. Let's see here, the voltage here. Okay, let's see voltage on the output of this power supply. .3, good, and it's going to 0. And this one, this one 5 volts and it's going to 0. Okay, these are working fine. Wow. Wow. I think we work for nothing. Yeah. Oh, we work for nothing. I can't believe that. I mean, I seen it weird from before, you know. I seen it. It's weird. I mean, it's taking too much current. But I said, you know what? Who knows? Let's just follow the, you know, the normal workflow to fix the board, and yeah. Okay. So we do have 3.3 on. We have 5 volts and 3.3. But when we are powering on the board, yeah, I will simulate the power button. I will simulate the power button. It's on, and look what happened. Off. Yeah, going off. So one more time, you can follow the current on the screen. On, off. You see, that's the point where you can't really do anything. Sorry, sorry. It's a dead chipset. So I believe the original issue, because the Super IO is reacting. Yeah, the Super IO is reading the power button, so I can power on the board. Okay, you can see, and the current is going up. Ah no, sorry, I took the plus out. Okay, the Super IO is responding, so the Super IO is good. Okay, we did have the 1225 buck converter, yeah, the driver dead, but now it's good. Now the Super IO is reading the power button. I press the power button. The Super IO is starting the board, but the chipset is dead. It's shorted. I mean, it's not shorted, but it's taking a lot of current. I'm really sorry. I wish, you know, I could fix it. I mean, on the first place, no point, because the customer doesn't want back the board. In the second place, to replace the chipset, it's not that simple and not that easy. Okay, pointless. But anyway, I try to make the guy who sent the things here, I try to make him happy because he asked for I can do a video fixing the board. So we restore the power supply, yeah. We restore the voltage on the Super I/O, but the chipset is shorted. How the chipset can get shorted? Usually the chipset doesn't get shorted, but when you start playing with, I don't know, like if you do mistakes, like coming with the power supply and playing with the power supply, bad things can happen. Or if you start like shorting like random chips, yeah. Okay, don't get me wrong, nothing wrong in that, yeah, nothing wrong. That's how you learn. So if you play on the board, next time you don't play like random because the things can get shorted, like on this case. But that's the learning process. The learning process is an expensive process when actually you broke or burn things, and everyone goes on that point. So it's nothing, make you feel bad. I mean, it's normal. You think I didn't burn like components, like wow, I burn a lot. That's how you learn. Okay, so I'll stop now. I'm really, really sorry. That you follow the path, and at some point, if you can, at some point, you get stuck like on a fall like this, and you cannot go further. Okay, so thank you for watching. Like and subscribe if you like the video, and see you on the next one. Bye.